point. Can anybody tell me what a point is? Any guesses? Any arguments? Okay. It is a specific spot or dot, right? What it does is it defines a specific location, right? So this would be an exact location in space with indefinite shape and size. And clearly, we know that points can exist on our number lines, like what we've been seeing the last few days. They can exist on those two-dimensional coordinate planes with an x and y axis, right? So, like he said, it is just a dot. We will name it with a capital letter. So, for example, this point could be named A, but it has to be a capital letter when naming a point. So I know some of us prefer to write all of our stuff in lowercase or all of our stuff in capital, but here it's going to matter which ones you make capital and lowercase. So make a note here that it must be a capital. Okay. All right, what about a line? Can anybody tell me what they think a line is? We talked a little bit about a line segment on Friday. So we said a line segment was part of a line because it had two endpoints. What about a line? Is it going to have endpoints? No, like it's going to continue indefinitely, right, in two directions. So an object with no thickness that extends infinitely in two directions. So if it's going to extend infinitely in two directions, I put arrows on the end to note that. And a line can have any number of points on it, right? So I'm going to put a few points on here. And I'll name my points X, Y, and Z. Remember, it doesn't matter what you're naming them as long as you use capital letters, right? Okay. Whenever you name a line, you just pick 2 points from that line. So I could pick X and Y. I could pick Y and Z. I could pick X and Z. And their order doesn't necessarily matter either, so you could do any combination of those letters. But to denote that it's a line and not a line segment or array, you draw a line above the 2 letters and you put arrows on either end. So it can be any 2 points on the line. So you can make a note of that here. Any 2 points. The second option is that it can be named using a lowercase script letter. When I say script, that means like cursive, right? So I could name this line L using a lowercase script L. And it would be called line L. If you name it this way, again, it's lowercase script. A line segment, we already talked about that on Friday, right? We said it's basically a part or a piece of a line. That has two endpoints. And all the points that are in between those endpoints. Alright, so our line segment has 2 points on either end. I'll call them X and Y. And there could be some points in between them. Doesn't have to be, but there could be. And we name our line segments, again, picking 2 points, but particularly they have to be the endpoints. So if there was a point here in the middle, let's say Z, I could not use Z when I name the line segment. I have to use the endpoints to name a line segment. So I could either name this one XY, or you can flip it around, YX, but the only options here are the start point and the end points. And to denote that it's different than a line, we put just a line with no arrows above it to show that it does not continue infinitely in 2 directions. So make sure you have that symbol above it to denote that it's different from a line. All right. Then we have array. Array is pretty similar to a line segment because it is a piece of a line. But this one consists of only one endpoint. And then on the other end, it's going to continue infinitely in that opposite direction. So this one's going to have one endpoint here and then continue in the opposite direction infinitely. Just like a line segment, it could have several points on it. Maybe I name those points again, just X, Y, and Z. Here, the way we name array is that, again, we pick 2 points, right? But the first point always has to be your endpoint. So for us, that would be X. So I could name it XY, or I could name it XZ. But the X has to be listed first, and then we put that symbol above it with an arrow pointing in one direction. Now, even if your array was drawn facing the other direction, your arrow in the notation is always going to point to the right. Okay. So here, you might make a note that the endpoint must be listed first. Okay, then we have what we call opposite rays. Opposite rays can look a lot like a line because it's going to appear that it's got arrows going in 2 directions, because the definition here is that you have 2 rays sharing the same endpoint and continues infinitely in opposite directions. So like I said, this could look sort of like a line because they share this endpoint, one ray going this way and one ray going this way. So it looks a lot like that line that we talked about up above. And then it can have points on either side of that endpoint. But what we really have here is this ray that started at point Y on either end. So this is what it's going to look like, but this is what we really have. Okay, the way you know whether it's the opposite rays or a line is going to be based on the naming protocol. That's how you'll know if it's supposed to be two opposite rays or if it's a line. So to name this ray, what letter do I have to start with? The Y. I have to start with the endpoint. So I would name this ray Y what? Good. And even though the ray points the other direction, our symbol always points to the right. Okay, and what would I name the other ray? YZ, very good. So no matter which direction, symbol doesn't change. Up above the letters, don't flip the direction of it. Okay. All right. And then last, here on the front page, we have a plane. So a plane is where our points are located, right? But as you guys know, on a coordinate plane, like where you plot points with some x and y value, the x-axis and the y-axis can extend infinitely, right? They go left and right forever, and it goes up and down forever. Okay, so that means that planes extend in all directions infinitely. This is a flat surface that extends infinitely in all directions. So our plane is just some large flat surface. To show that it extends infinitely, obviously we can't draw that, so just like our lines, we just put arrows going off in each direction to show that it should be extending in all directions. Okay, obviously there can be several things plotted on a plane, right? You can have points, you can have lines, rays, line segments. I'm just going to put a few different points in here. Maybe this time we name them L, M, and N. Just make sure we use our capital letters there. To name a plane, you have to use 3 points. Okay? So if there were more than just these 3 points, you could pick whichever ones you want, and it doesn't matter which ones you put first, last, in the middle. You just pick 3. Right? So this could be L, M, N, or any combination of those letters. If you wanted it to be N, M, L, it could be N, M, L. But it just has to be 3 points. Okay? And then kind of like our line, You also can name a plane using a script letter, but a plane would be a capital script letter. Okay? So it's kind of hard to do just a single script, but maybe we do capital P. Then I could name this plane P. Okay, but make note that it is going to be uppercase script. I feel like they use P and R most commonly for planes. Oop, I said plan. Plane. All right. Okay, if you'll flip it over onto the back, we have a couple more terms to talk about here. Okay, next we have what we call collinear. Collinear just means you have points that lie on the same lines. So if we had that same line that we drew as our example on the front that looks like this, had those 3 points, X, Y, and Z, those 3 points are on the same line, so we would be able to say that points X, Y, and Z are collinear. Alright, so if collinear means that you've got points that are on the same line, what do we think non-collinear means? Right. So points that do not lie on the same line. So maybe we still got that same line with our points X, Y, and Z. But we also have another point in our plane, point W. Then you would not be able to say that all 4 of these points are collinear because W is not on the line. So W, X, Y, and Z are non-collinear. Alright, and if collinear means points on the same line, what do you guys think coplanar means? Points that are on the same plane. Very good. So remember, to represent our plane, we just draw some flat surface with arrows extending in each direction to show that it extends infinitely. And I'll put 3 points inside of there. Maybe this time it's Q, R, and S. Then I would be able to say that those 3 points, Q, R, and S, are coplanar. So if coplanar means they're on the same plane, non-coplanar must mean they're not on the same plane, right? Again, maybe we have that same plane. with our points Q, R, and S. Okay, so maybe this is that plane that has Q, R, and S. But then maybe there's this other plane over here, right? So I can't draw 3D, I'm not that good of an artist, but let's pretend that the point that I'm about to put down is in this plane that's existing, that's running vertically, while this one runs horizontally. If there's a point up here, obviously if it's on this plane, it can't be on this plane, right? So I'm just going to put a point out here to the side. So those 4 points, Q, R, S, and T, are non-coplanar. All right. All right, and then we have our angle. So you guys are probably more familiar with seeing this. You've had to do stuff with these in the past. Our angle is made up of 2 rays that share a common endpoint that we call a vertex. So it doesn't say they're opposite rays, it just says that it's 2 rays. They could be opposite rays, but it doesn't have to be. They just share this endpoint. So if that's my endpoint, I could have 1 ray going up diagonally here and then 1 ray running horizontally this way. They share that common endpoint, and we call that endpoint the vertex. Remember, there can be points on either of those rays, right? So maybe these are points X, Y, and Z. So I named my vertex Y here. The correct way to notate an angle, or to name our angle, is to pick 3 points. Okay, so if there were other points besides X and Z on those rays, you could pick other letters. But the vertex has to be the letter that you put in the middle. So we could name this X, Y, Z, or we could name it Z, Y, X. Either one is fine. But the Y has to be in the middle. Okay? And then for the symbol in front, you draw a little angle, and sometimes people will put arrows on it, sometimes they don't. The arrows are not a necessity. What is important is that the Y is in the middle. You also could name this just angle Y, but you can only do this if it's the only angle existing there. If there was a 3rd ray, then we wouldn't know which angle you're referring to if you just name it Y. So you can only name it this way if it's the only angle at Y. So we can name it this if only angle at Y. All right, and then we have our vertex. Well, we just said that Y is the vertex, right? This is that common endpoint that is shared in our angle. Whenever you have an angle, this point that they share right here, that's your vertex. Maybe I'll just call it X this time, but this would be the vertex. Okay, and your vertex is always just a point. And remember, we said we always name a point with a capital letter, right? So here, it could be X. Sometimes they will put the symbol of a point in front of the capital letter, so either one of those is fine. but just know that a vertex is just a point, so we name it the same way that we said we would name a point. Okay. All right, last we have our intersection. So can anybody tell me what an intersection is? Where what?
Two rays across each other.
It could be where two rays are crossing each other. It could be where any two things are intersecting each other, okay? So it could be where a point or line, where they are intersecting two or more objects. Alright, so let's look at the different scenarios we can have. Like you said, it could be two rays, two line segments, right? Those all would intersect at some point. So we're going to draw 3 examples, so you might want to draw these ones a little bit smaller than you have been drawing. Okay, so 2 lines, 2 rays, 2 line segments, whatever you want them to be. They all intersect at that point right there, right? Maybe we call that point X. Then I would say their intersection is at point X, right? Okay. The second scenario is that maybe we have a plane. I'm going to do my best to try and draw this 3-dimensionally. But pretend this piece of paper is my plane, right? And then I have a line, like this pen, that's running through the paper, right? So the plane runs horizontally, my line is vertical, so it comes out the bottom. This pin would intersect my plane right where it touches it, right? So it would intersect at one particular point. So something like this. I'll name this point Y. So the intersection for a line and a plane would be a point as well. Okay, and then our third possibility is that we have 2 planes that are intersecting. So maybe this is my plane running horizontally. This is my plane running vertically. Remember, planes extend infinitely, right, in all directions. So obviously my paper doesn't, but if it runs into this piece of paper, it's going to come out the bottom, right? These 2 pieces of paper are not touching at just one point, like my line and my plane were, right? They touch all along that edge there. And these edges should be extending infinitely in all directions. So all along this edge forever, that would be a line, right? Where these 2 are intersecting. So for our third picture, hold on, let me give myself a little more space. Try that again. Okay, so we've got this plane here, like this one, and then one running vertically. So maybe something like this. They would intersect all along here, right? So they would intersect along this line. I'll call it line L. So their intersection would be line L. So depending on what you have intersecting, the intersections could be different things. 2 lines intersect at a point, which you guys already knew, right? When you learned how to graph for a system of equations, you said that they cross at a point. We should also now know that a line and a plane will still intersect at one point, but now we know 2 planes intersect along a line. All right? Okay.